Usually when you hear 96 gigabytes of VRAM, you expect something absurdly expensive, like this NVIDIA RTX Pro 6000, which was 10 grand, but now it's down to 8,500, but still. However, this right here might be the most affordable 96 gigabytes of VRAM you can buy in a single system right now. The question is whether cheap VRAM is actually useful or just cheap. But this server has 4 Intel Arc Pro B60 cards in it. Yes, Intel is continuing the Pro line, and Intel's pitch here is pretty clear. Each B60 has 24 gigabytes of GDDR6, so together that gives me 96 of total VRAM in one box. 456 gigabytes per second of memory bandwidth, which is useful for LLMs, the decode phase of it. If you've been watching this channel, you know what that is. It also has about 200 watts of board power, and this particular version is the Sparkle card, and it's listed at $799, but I've seen it on Newegg for $650 for 24 gigabytes. NVIDIA's previous generation 4090 has 24 gigs of VRAM, and this one cost me over 2 grand. The newest Blackwell generation 5080 also has 24 gigs, and that one, even though it's listed at $1,000, you probably can find it for $1,500 to $1,800 now. So on paper, this looks like a pretty simple idea. A lot of VRAM for not that much money. So I wanted to compare this to a couple of GPUs in the same price range. What's available? Well, from AMD, we've got the RX 7900 XT. There's nothing in the Pro line from AMD that's close to the price. And from NVIDIA, we've got the RTX Pro 2000 Blackwell. Yes, same generation as the big brother, but this is a tiny little one with very different specs, yet it carries that Pro name and the price tag. The RX 7900 XT goes in a very different direction. This one has 20 gigabytes of VRAM, not 24 like the Intel. That means it'll allow you to run smaller models. But all these cards will run smaller models by themselves. This one will just allow you to have less context and less KB cache. However, this card has 800 gigabytes per second of memory bandwidth and 315 watts of board power. So compared to the B60, AMD is basically giving me less memory, but a lot more bandwidth and a lot more power. The RTX Pro 2000, it's a bit of an oddball. It has 16 gigabytes of GDDR7, so the brand new memory, but it only has 288 gigabytes per second of memory bandwidth, and it uses 70 watts of power, which means you don't need extra power cables to run it. It just gets this power from the PCI bus. But this cost me $800, so price is up there. Now, NVIDIA's angle is almost the opposite of Intel's. There's less VRAM, much less bandwidth, way lower power, and a much smaller card. So those are the things you get for that price range. Now, the B60 is not trying to be the fastest GPU. It's just trying to be the GPU that gives you the most VRAM density for the money. And once I stack 4 of them into one server, that becomes the real question. Is cheap VRAM actually useful, or is it just cheap? Can we actually use this and get good results? We're about to see. As devs, our info ends up everywhere. Repos, bug trackers, random API signups. That turns into a profile that data brokers can package and resell. The harder you are to find, the harder you are to target. In a lot of countries now, the law says data brokers have to remove your info when you request it. But doing it yourself means hunting down hundreds of brokers, dealing with each one, and checking back again later. Incogni fires those removal requests automatically and keeps following up until they comply. My own dashboard showed hundreds of hits connected to my details, and most of them have already been taken down. And when I find a specific page exposing my info, I use custom removals. It's easy. I submit the link, and their team handles the takedown and follow-ups. You can think of it like this: find it, remove it, and keep it removed. For an extra peace of mind, Deloitte verified their data removal processes. It helps with broker sites and eligible pages, but it's not for things like official records or random social posts. You're on your own for those. And if you want to test it out first, there is a 30-day money-back guarantee. Take your personal data back with Incogni. Go to incogni.com/AlexZiskin and use code AlexZiskin for 60% off an annual plan. Link down below. I'm gonna kick things off with the RTX Pro 2000 comparison because it's already near me and I don't need to plug anything in. It's nice. Boom. Oh, this is just to get a flavor of how these cards compare. So I'm going to use a relatively small model, but remember, it needs context. So even the Qwen 34B model, we're running the full BF16 on all these machines. That one is 8 gigabytes. It's already half the memory of what's available on this RTX Pro 2000. Yeah, you're not going to be able to run huge models on this, but this will give us a little comparison point of how perhaps these machines will scale. In actuality, when you scale them out, it might be a little different, but I don't have 4 RTX Pro 2000s or 4 of the AMD cards. I do have 4 of these, and we'll get to that. So I'm gonna kick off VLLM, and we're gonna use VLLM throughout here. I'm gonna keep an eye on NVIDIA SMI here. We've got 70 watts maximum for this GPU. And over here on the Intel box, this is showing us that I have 4 GPUs installed, 0, 1, 2, and 3, but we're just gonna be using the 0 GPU for this test. And over here, I'll kick off the same exact model, but using the Intel version of VLLM, and I'll get into that in a moment. Here, I'm gonna run Llama Benchy, which is a nice tool by Uger. You can find it on GitHub, and it's really a good tool because of its flexibility, and it works kind of like Llama Bench, but across HTTP, and you can run it against any backend. First, let's do concurrency of 1, which means it's gonna do only 1 request, simulating kind of like a chat scenario. And boom, there we go. You can see we got that request right here in VLLM, and we're using 69 watts of power out of 70, so pretty much maxing it out. Prompt processing, 5,223 tokens per second. NVIDIA is really good at prompt processing speed. Even on such a tiny GPU, that's really impressive. 27 tokens per second for token generation. Remember, this is a BF16 model, even though it's a small one. Now let's do this against the Intel box. What? I think I named my models differently there. Indeed. Let's copy that model name. And there we go. You can see that this is only using that 0th GPU, not the rest of them. And we got 17% utilization. Not great. About 120 watts of power also. But look at that. 22 gigabytes is being used up on that machine, which has given us all that extra cache, all that extra space for the context. That's where it's really handy to have more VRAM. How's the speed? Whoa! I mean, it does have higher bandwidth, much higher bandwidth than the NVIDIA GPU. 9,576 tokens per second for prompt processing, and token generation is 45 tokens per second. Now what happens if we change the concurrency to say 32? So that means 32 requests at a time is being handled. Send that over, and that's going to the NVIDIA GPU right now. There you can see that we got a bunch of requests at the same time. They're all being processed. So this is gonna take a little bit longer. 69 watts being used out of 70. And this is the entire system. 158 watts being used right now by this entire computer. I mean, it's kind of not a fair comparison because this is a very different kind of system than this server. This is an AMD desktop chip, and this is a server-based Xeon machine. And it's done now, and while it's done, we're down to 75, 74. Okay, that makes sense. Whoa, so the prompt processing speed went down a little bit, 1,313, but the token generation went up, 232 tokens per second because we've got higher concurrency. Concurrency 32 on this box. Oh, do you hear that? It's like an airplane over here. And just with that 1 GPU on this machine, we're using 524 watts of power. Of course, when it's idle, it's already using 350. All right, 7,941 tokens per second for prompt processing and 497 tokens per second for token generation. I think we have improvements in both areas there. Ah, that's hot. That's even hotter. Wow. All right, now let's try the AMD GPU, which has the highest bandwidth out of all these. And this one needs not 1, but 2 8-pin power cords. It also has RGB, or maybe just B. Wow, that is getting pretty toasty. I can feel it on my face. AMD is ready to go. Application startup complete. VLLM on this one also, but again, a slightly different VLLM image, one that targets the AMD platform with ROCm. First, let's do concurrency of 1. And boom, there it goes. And this one has the most coil whine. It's actually a pretty quiet GPU because it's meant to sit on somebody's desk as a gaming GPU, but the coil whine is definitely there. What? Are you done already? Wow. This is in fact the fastest TG we've seen so far. Prompt processing 5,211. Actually, not too bad. Token generation is faster because we have that higher bandwidth. Since this is the only one that's not a pro GPU, let's see how it does in concurrency of 32. And while it's running, oh boy. Yeah, 480 watts of power being used by that whole system, which means, wait, 400 watts being used or so by the GPU? That kind of exceeds what I expected. It's done. Really? You're done? 5,114 tokens per second for prompt processing, and this is with concurrency 32, but that number hasn't really changed that much. 431 tokens per second for token generation. So much better throughput there. But the Intel card beat it out, which is kind of interesting. Now that was 24 gigs. What happens if we run all 4 GPUs with 96 gigs? We can run bigger models. Now I've got all 4 GPUs in the machine, and I had to move it off the desk because, well, as you can hear, it's a little loud in here now. Also, if my cameras die, it's from the heat. Pretty toasty in here. Here are the 4 B60s, and I'm also monitoring the server output here. These are the 4 GPUs, GPU utilization, how much power each one is using, and the last column is the memory. So right now, it's not using much at all because nothing is running on it. As it stands right now, we're at 372 watts of power for the entire system. 4 GPUs capable of 200 watts, and that whole Xeon processor, motherboard, RAM, server class components. I would say that's not too bad, but once we spin it up, let's see what the usage is going to be. To take advantage of tensor parallelism with 4 GPUs like that, you need to run larger models. Let's start with a mixture of experts model. I'm going to set my tensor parallel size to 4 so that it's taking advantage of all 4 GPUs. And I'm going to set the host to 0000 in VLLM so that it exposes the endpoint to my LAN, so I can use it from other machines, like a server. Now I'm using a version of VLLM that's slightly behind the most recent version of VLLM because we're following the Intel stack. And that's one of the downsides of this. You don't get the latest and greatest models because you kind of have to use their stack, which is this Intel LLM scaler. And you can see it's on GitHub, open source, what models are available right now. And right now it's mid-March 2026. Sure, we have GLM Flash available, that's great, but we don't have Qwen 3.5 anywhere, even though that is something that's available now. It's the latest and greatest in coding. I know some of you will have your own opinions, but you know, it's not yet available here, unfortunately. So this is probably like a few versions behind. And from what I've seen, their cadence is probably about a month or so. Did you hear the noise level in here get a little bit louder? Yeah, you're not the only one. I'm the one that has to put up with this heat right now. Well, the screen kept dying on this one and kept logging me out. So we're gonna do this remotely. I'm on my Mac and I'm remoted into that machine through SSH, and I believe we can get it going that way. Whoa. So I'm running Llama Benchy right now, and it's getting a lot louder in here. Now, while that's happening, I want to show you the power usage here. We're using 933 watts of power now. Oh, down to 810. But those GPUs are not getting close to the 200 watts that they're supposed to be. Well, I don't want to say supposed to, but that's the maximum. I'm getting about 120 to 130 per GPU here, according to this monitor at least. Well, they're maxed out. They're at 24 gigs each, and we're getting about 21% to 22% utilization on each. So it's not the maximum. We have more headroom for utilization and power, just not memory. I'm doing concurrency of 64. Why am I doing that? Because typically you would be using this as an agentic server, for example, doing multiple requests at the same time, sub-agents, or you may have this set up in an office scenario where multiple people are connecting to the machine at the same time. So we've got a peak of 574 tokens per second. And by the way, I reran this as the distilled version of DeepSeek R1, Qwen 32B. This is the full BF16 version. 65 gigabytes is the total size on disk of this model. So it's pretty chunky, it's a dense model, and the peak throughput is 574 tokens per second, 289 tokens per second sustained for generation, and 1425 tokens per second for prompt processing. 64 is probably the maximum concurrency we would see on something like this. If I go to 32, we can take a look at that too. By the way, I did try different concurrencies before, 128, 256, and there's diminishing returns on those. So 64 is the most I've seen. 940 watts, that's the most. This thing is angry. Whew. It's hot and loud in here. I hope the mic can pick me up. 309 tokens per second sustained, 512 peak. But prompt processing went up to 2,931. I'm gonna try this one, Qwen Coder 30B, and this is an MOE model, mixture of experts, so it's gonna be active 3 billion parameters. Let's kick that off with VLLM. And this model is also the full BF16 version, 61 gigabytes on disk. So these are pretty chunky. Now, unfortunately, I don't have multiples of the AMD GPU and multiples of that NVIDIA RTX Pro 2000 to do the comparison for those. But even if I had 4 of each one of those, they have a lot less VRAM, so they would not be able to run these models, especially with the amount of context that we're looking at here. These are pretty toasty over here. Here I can put my hand on this. Not recommended, by the way. Just stay out of your case, all right, folks? I'm doing this for an experiment. However, over here, this is very hot. It will burn me if I leave my finger on there. It's extremely hot. Yeah, do not touch that. Okay, it started. These models are big. It takes a while to load in VLLM. It just takes a while to load them up. So this, let's see, this took probably, this took like 7 minutes to load while I'm standing here like an idiot looking at it. Folks, walk away while VLLM is starting up. I'm gonna run llama benchy against it, and we'll start with concurrency 32, but I do have to change this model out. Quencoder 30B instruct. And boom, and there it goes. 24 full gigs on each of the GPUs. Right now we're about 60 watts of power being used and about 22 utilization, 22%. It says it's warming up right now. It doesn't usually take this long to warm up, and we're hovering at about 450 watts of power being used by the machine. Something's up. I'm gonna stop this. Let's do a little curl for models. This is how we find out what models are loaded, by the way. Curl, then the IP, V1 models, and then it says that this is loaded, but just make sure I'm using the right ID there. Let's try that again. Okay, so we did get the models endpoint reached. I just ran it for concurrency of 1 and 12,800 tokens per second for prompt processing. That's pretty decent. That means if you have a longer prompt, which typically when you're using this as an agent or a code assistant, you send a lot of information in there. That is really nice. Now, token generation, 27, not the fastest thing out there, but it is a pretty big BF16 model. Still, being an MOE, it could expect a little more than that. But what does that really look like? What does that translate into? So let's take a look at what this looks like with a higher concurrency. Again, concurrency of 1 is like chatting with it. Concurrency of more than that would be using an agent or using it in an office scenario with multiple people at the same time. Well, it gave me crazy amount of tokens per second for this one, but it did not like so many requests being sent for this particular model. We're just coming up to the limit. I wanted to use a bigger model here, but for 32, this is the second time it failed on me. So that's crazy. 311,000 tokens per second for prompt processing, which is pretty good, I'd say, because per request is doing 12,000 tokens per second for every request. And yeah, we can see that the server had finished the process, application shutdown complete, but we got some errors. That's not what we wanted to see. You kind of have to walk a fine line there between giving it too many requests and finding that optimal spot where you get the most throughput. All right, I restarted it, and fingers crossed this won't do too many requests because I do have the agent mode selected here. I'm just gonna start with ask first for a little chat, and I'm gonna select other models here. I'm in VS Code, of course. I've already configured the Quencoder 30B running on that machine as my model. Let's see. Hi. Oh, well, that model was giving me some issues. So in order to demonstrate how this works with a coding agent, for example, so I went back to the model that was working, DeepSeek. That seems to have handled a lot more concurrency, and I configured VS Code with that model. So I just need to go here, manage models, DeepSeek. So I just need to go in here and select DeepSeek model here. Let's go with ask first, just to make sure it's communicating correctly. Hey, look at that. It's actually working. Why am I surprised? I shouldn't be. It's just always fun to see when things work out. And look at that. There's the usage. We got about 15 to 17 utilization with 114 to 120 watts of power per GPU. And we got a little answer there, including the thinking, which is not parsing properly, but you know, everything is fixable. Let's see if an agent will work here. What is this file? Boom. Yep. It's recognized what file I'm looking at. First, I recognize that it's a configuration file in a Python project. It's doing pretty well. This is what, 27 tokens per second or something, but it's not bad. So this is an example of real usage, and we're at about 800 watts for the machine. Figured out what it's doing, and so on. Of course, the different kinds of models that are going to use going to give you different answers. Some are going to be better than others. This is just a demonstration of what's possible on this machine right now. Now, some of the newer models, like GLM Flash 4.7, which I did try, could not get it loaded with this version of VLLM. Hopefully that'll be fixed soon, even though LLM Scalar repo does show that model as being supported. So that's where we are right now with the professional desktop workstation type of cards, GPUs from Intel. 1 second. Yeah? Oh. I think I spoke too soon. The flagship is here. Oh, you might want to get subscribed because we're doing that next time. Thanks for watching, and the B50 video is right over here. I'll see you next time.